Hello everyone. In this video, we are going to introduce you to our IoT platform CovidCare and the main concept behind it. The general purpose of the platform is to provide home monitoring services for COVID patients from the ability to measure his/her temperature, oxygen level, blood pressure, and heart rate. The monitoring of the patient is done remotely and provides fast response to critical condition in case of an emergency. The platform is composed of multiple services that are built using the microservices architecture that communicate by exposing MQTT and REST. Now let's have a brief look at these services. First, we have the catalog, which acts as a registry system for all patients, doctor sensors, and other services in the system. It utilizes the REST service for communicating with other microservices. At the center of the platform, there is a broker. It acts as a medium for all services communicating with MQTT. It receives the messages from the publishers and routes them to the subscribers. Then we have the simulated sensors, which retrieves the patient's temperature, oxygen level, blood pressure, and heart rate. The sensor verification is used to verify that all sensors are working perfectly and notify in case if one of the sensors has stopped working. The timeshift microservice is a publisher to the sensors. It varies the limits of the measurement of the sensor depending on the time of the day. The signal monitor is for analyzing the obtained data from the sensors. It also notifies the ambulance service in case the patient is in a critical condition. The ambulance service is used in case the patient is in a critical condition. It retrieves the patient address and sends an ambulance to them and notifies when the patient has been visited. The ThinkSpeak adapter retrieves the data from the sensors, and after receiving the data, it uploads them to the ThinkSpeak platform by means of REST web services. ThinkSpeak is a third-party platform available as a platform as a service. It receives the data coming from the adapter by means of REST services. The data is stored and updated continuously. A patient manager creates or deletes the channels of the patients on ThinkSpeak automatically whenever a new patient is added or deleted from the catalog. Node-RED is a user-friendly dashboard for visualizing the parameters of the patients. The dashboard can be accessed using a specific URI or from the doctor Telegram bot. And finally, we have the Telegram bot. It's a service for integrating the platform on Telegram messaging app. 3 bots are used in our platform. First, the doctor bot, which is used by the doctors for monitoring the patients. Then the patient bot used by the patients, and lastly, the family bot for the families of the patients. All of the platform is run on top of Microsoft Azure Cloud. Now, let's have a better understanding of the platform.
For starting the demonstration of the project, we need to initialize the services. We can see that the catalog is running in Azure, and since it has just started, there are no patients and no services registered yet. Only general information for the services to be able to start, like for example the broker information and the tokens. First, we can start by running the timeshift and see how it gets registered in the catalog. Then we start the sensor verification, the signal monitor, and the ambulance. Now we start the services running on Azure that are Node-RED, Patient Manager, and the Telegram bots. Finally, we can observe that all the mentioned services appear now in the catalog with the necessary information for them to work. They also have a timestamp that needs to be updated. In case this doesn't get updated, the catalog will delete them.
First, before registering a patient, we have to register a doctor by registering his name and ID. And then we proceed to do a GET request. We notice that the doctor has showed and there is no assigned patients. Now, let's proceed to registering a new patient. First, we start by registering his patient ID, his surname, his name, and address which will be required for the ambulance service, and the age, and the pills that he will require during the treatment. And for the COVID status, we will leave it as positive to be registered to a doctor. but in the case it was negative, he will not be registered to a doctor. And then we choose the daytime parameters, which range between a minimum and a maximum interval for all the parameters. And for the nighttime parameters, we will leave it empty since it's gonna be the same as the daytime parameters. Now we will do a GET request to the patient's URI, and we will see that everything has been added to the catalog regarding the patient, and his COVID is true and all the parameters are available. Now we'll do a GET request to the doctor URI. We will see that the patient has been assigned to a doctor.
Every time a new patient is added, the TN Patient Manager service creates the corresponding ThinkSpeak channel for that patient. The channel has a field for each of the 5 measured parameters: temperature, oxygen saturation, heart rate, systolic blood pressure, and diastolic blood pressure.
Now we are going to see how the sensor register on the catalog. First we can see there are no sensors yet on it, so we run the first type of sensor, the oxygen saturation and heart rate. First it's going to ask which number of sensor we want to initialize, then the ID for the patient associated, and finally for the range we want to simulate. In this case, oxygen saturation value in healthy state and for heart rate resting. So we can see as a result the first message of the measurement sent to the catalog in the registration. Now we repeat the same process to register the blood pressure sensor. Again, we select one sensor, the patient ID 89 and range case is normal. Finally, the temperature sensor in the same way as the previous one with healthy state. So now we will check on Postman if they have registered successfully on the catalog. Let's click on JSON format to see it better, and here they are. Every type of sensor has registered correctly.
The sensor verification service will check if the sensors are working properly and allow the other services to use these values. First, we will start the sensors from a patient in a normal working situation. As we can see, the status of the sensor continues to be good and working properly. No notification is sent because we knew the status. When we set the sensor to error, we see that the patient receives a notification because the status has changed to not working, and the status is sent to false. Finally, when the sensor goes back to working properly, the patient will receive another notification to know the problem has been solved, and the catalog will be notified about it. The status has changed to true.
The ThinkSpeak adapter service is an MQTT subscriber of the sensors. Every time a new measurement is received, it waits until the sensor verification service verifies the sensor, and after this, in the case that the sensor is working fine, it will publish the data into the corresponding field of the ThinkSpeak channel of the patient, as it can be seen in the video. In the case that a certain time limit is reached before the sensor verification verified the sensor, the data will be ignored. The same happens in the case that the sensor is not working properly.
Node-RED dashboard is a user-friendly interface that allows us to visualize all of the parameters of the patients as sliders, which makes it easier to understand for a regular user. Also, it can show the plots of ThinkSpeak as they are updating concurrently.
Let's see the doctor's plot. In order to boot it, the doctor will press in start, and first is going to ask who is he or she and need to press on the button with their name. That is going to show the patients they have and can check information about. When one is pressed, he can choose between the sensors to fill this information. If sensor is chosen, it will show every sensor of the patient. For each sensor, he can consult the historical values, minimum, maximum, and mean, and also the minimum, maximum, and mean of today's values. Additionally, he can consult the last value registered on the sensor and also request for an instant measurement if they want to take it. On the sensors menu, he can click on See Graphics of the measurement, and he will get a link in order to see it on the browser, as we can see it. On the other hand, he can also consult the pills prescription to the patient, and for each of them, see when was the last time he took it or send a message to the patient in order to recall to take it. The patient will receive the message on their bot and register when they take it.
Regarding the patient's bot, when the patient boots the bot for the first time, a welcome message is displayed. The first task the patient needs to do is to register himself using the command /register, because if not, he won't be allowed to perform other tasks. The patient needs to choose his ID. Once registered, the patient can, for example, check his health status using the command health status, and the bot will retrieve him his status. The patient can also register a pill he took using the command register pill, and then choosing the pill he wants to register. Another important feature related to the pills is that the patient is able to check the last time he took a certain pill by just using the command pill time and clicking on the pill he's interested in. In reference to the family bot, when the familiar of a patient boots the family bot, a welcome message is displayed. He needs to register to proceed. He clicks on the patient ID of the familiar he wants to register to. After registering, he can obtain information of his familiar using the command health status. A familiar can be registered to more than one patient. He can also see to which patient he is registered to. Furthermore, he is able to retrieve information about all of them. Last but not least, he can decide to unregister to them one by one.
Now we are going to see how the signal monitor works. First, we are going to make a sensor throw an error value, and as we can see, the patient receives the notification, but no alarm is set. Then we fix the error and he is notified. Now the data can be processed by the signal monitor. Now the patient has turned into a critical condition. This causes an alarm message saying that the ambulance has been called to the patient, family, and the doctor. Also, the ambulance service receives the call and all the necessary information to visit him. The ambulance service can also take a look at the list of patients to visit, only showing the ID, list, or the full information. Once the ambulance has visited the patient, he can be removed from the list, and this will also notify the family and doctor of the ambulance's visit. If the patient reaches a serious condition, the doctor will be notified so he can take further actions. In this case, we are going to simulate a COVID-negative patient whose parameters are the default of a normal patient. Once registered, we see that he appears in the catalog with COVID key with a false value. We now see the doctors, and as we see, the patient with ID 27 has no doctor since he is fine and might not be necessary to have a doctor controlling him. We will now simulate a temperature sensor of him. First, we will see that when he is healthy, he still does not get assigned a doctor. Instead, when we say that the patient has fever, on the down left screen, the signal monitor tells us that the patient status is serious and gets confirmed of COVID. For this reason, he should be assigned to a doctor, as we see in the catalog. Also, going back to look at his data, we can see that now he is COVID true.